Hello and welcome to the second part of the Matlab video tutorial. Today we'll go deeper into the topic of matrices and vectors and how to access elements or areas inside a matrix, and also how to initialize special matrices like the zero matrix or identity matrix. Also, I will show you how to transpose or invert matrices and how to find the determinant of a matrix. To do that, we simply take our M file from the last video by selecting the correct folder up here, first exercise, then double click on the M file and our editor will open up. But for this we don't need the whole source code from last time, so I'm just gonna delete the second part of it because I only want to use the editor to create a matrix. So I'll just type in A equals in square brackets 1, 2, 3, next row 4, 5, 6, as you remember from the last time, and run it. And you'll see that it will show up in the workspace. Now, how do you access the values in the matrix? You just type in the name of the variable, followed by round brackets, and the position indicated by the row and column. And then you'll get the value. At this point, it is useful to show you the array editor, which opens up if you double-click on the variable, and then you'll see the matrix in the array editor. I don't like the position here, so you can just change it by drag and drop and put it somewhere you like, for example down here. We can also access other positions inside the matrix by just changing the number of the row and column, for example 2 and 3, so we get 6. Sometimes you try to access values inside of a matrix that don't exist. If you don't pay attention to the dimension, then this arrow will show up. You can also access whole rows or columns of your matrix. For example, if you want to access column number 1, you just type in a colon and column number 1, and you will get the first column of your matrix. This is the same if you want to access a whole row. So you just again type in a colon and row number 2. So you will get the second row of your matrix. If we want to see a certain area of a matrix, for example, in this case, I only want to see the values of column 2 and 3, I type in the name of the matrix A, the rows I want to see number 1 and 2, and also the columns from 2 to 3. The area here is marked by the colon. If we want to know the size of our matrix, we can type in the command size of our matrix A, and then we see it has 2 rows and 3 columns. We can also set a name for this size, so we get a vector of 2 and 3, and then we can access the values from the vector dimension by typing 1 for rows and 2 for columns. For later computations, we definitely need predefined matrices. These can be, for example, the zero matrix. We can type in zeros and then the dimension 3 times 3, for example, then we get a matrix only consisting of zeros. This also works for ones, so we get a matrix only with ones. If we want to create an identity matrix, we type I and then the dimension of it. Be careful that it is squared because only this works for identity matrices. We can also set up a random matrix. This is done by the command rand and then the dimension of it. For example, 4 times 4, then we get a matrix of this kind. So what kind of operations are there for matrices? To see this, I'll just create a new matrix. Well, I can use this one, but I will just add a new row. So 7, 8, 9. And to transpose this matrix, we just type in the name of it and add an inverted comma, like an apostrophe, and then we'll get the transposed matrix of it. We will also need to invert matrices, and to do that we either set the matrix to the power of 1, or we use the command inv for inverse and type in the name of it. The result should be the same. We can also see the rank of our matrix or the determinant of it by the command det and type in the name of the matrix. And to see the trace, we type in trace of our matrix A. And also, if we want to see the diagonal of it, type in diag. Keep in mind that there are many more operations than I am showing you here. And if you want to see those, just click help, and then the help window opens and you can search for a command, for example this diag command, and then on the right side you see the syntax of it and also the options you have and description. And what is also useful is this see also section. This is a good way to learn more about the commands we have. Now I want to show you another way how to create vectors and matrices. For example, I now want to create a vector containing the values from 1 to 10. And for this, I'll just initialize the vector by setting a name, and in square brackets from 1 colon to 10, close it, and then I get the vector from 1 to 10. If I want to vary the step size of it, I'll add the step size in the middle of my starting and end value. So for example, step size 2, and then until 10. I can also change the step size. For example, if I want a smaller one, I type in 0.1, and then I will get a large vector of values from 1 to 10 in a step size of 0.1. So if we see it here in the workspace, it is quite big. Now, why do we do this? Well, for later computations, for example, we can set up a vector from 0 with a step size of 0.01 to 2 pi. I'll just enter a semicolon here so we have no output. And then in the array editor again, we can see that our vector goes from 0 to 2 pi in a step size of 0.01. And now we can create a second vector which doesn't contain the values from 0 to 2 pi, but the sign values of our previous vector. And if we then assign our two vectors to the plot command, we can create a simple sign plot. So I'll type it in here, plot vector and the sign values of it. Then the plot window will open up and we see the sine curve exactly from 0 to 2 pi as we defined it in our vectors. As a short preview to my plot tutorial, which I'm also gonna do, I'll just type in R for a red curve. So you see the plot now is in red, or in green with stars. I'll type G and a star. Or if you like, for example, yellow with dots and lines. We can also simulate vectors by using the random function I just showed. Imagine we want to create an observation vector because we have measured a distance of 30 meters 20 times. So we'll set up the observation vector L, which is 30 meters plus random vector of 20 rows and 1 column for the deviation of the measurement. And then we have the simulated observation vector. We can also calculate the standard deviation and mean of our vector. For mean, we just type in mean of our observation vector, L. And for standard deviation, we use the function std. We can also display the minimum value or maximum value of our observation vector. And that's it for today. So make sure to look at the commands we just discussed in the help section, and see you next time.